Let's I check the attendance. The class TT01. Okay. Yeah, sorry. This morning I have the phone calls here, so I have to answer the call. It's a little bit late for our class. Okay, let's I record the video. Wait a moment. Yeah, recording. Okay. Yeah. Okay, so let's check the present in the class. Today is 25 December. Nguyễn Khoa Bách, are you here? Yeah, I can see your hand. Tiến Dũng.
Yes, sir.
Hey, Đoàn Dũng. Đoàn Dũng, are you here? Việt Dũng.
Yes, yes, sir.
Đình Duy.
Yes, I'm here.
Anh Hải.
Yes, I'm here.
Vĩnh Hảo. Minh Hoàng.
I'm here, sir.
Trần Minh Hoàng.
I'm here. Thế hôm nay em xin phép có buổi tiêm vaccine thầy nhé.
Ok em. Quách Gia Hưng.
Yes, I'm here.
Quang Huy.
Yes, I'm here.
Giang Huy.
Yes, I'm
Huy.
Yes, I'm here.
Bảo Khang.
Yes, sir.
Huy Khang.
Yes, I'm here.
Quốc Khang.
Yes, I'm here.
Nguyễn Khiêm. Nguyễn Khiêm, are you here? Anh Khoa.
Yes, sir.
Nguyễn Khiêm, ok, I see you. Anh Khoa. Nguyễn Vũ Anh Khoa. Ok. Huỳnh Minh Khôi.
Yes, I'm here, sir.
Lý Đức Kiên.
I'm here, sir.
Trần Hoàng Lâm.
I'm here, sir.
Nguyễn Quang Lộc.
I'm here, sir.
Nguyễn Tấn Lộc.
I'm here, sir.
Nguyễn Thành Lộc. Thành Lộc. Lộc Thiết. Phan Hoàng Lê Minh.
I'm here, sir.
Vũ Quang Minh.
I'm here, sir.
Đỗ Hạo Nam.
Yes, I'm here.
Võ Quang Thanh Nghĩa.
Yes, I'm here.
Nguyễn Hiếu Nhân.
Yes.
Hoàng Trí Quân.
Yes, I'm here.
Lê Hoàng Anh Tài.
Yes, I'm here.
Huỳnh Ngọc Tân.
Yes, sir.
Nguyễn Quốc Thắng.
Yes, sir.
Trần Bá Thành.
Yes, sir.
Thái Quang Thịnh.
Yes, sir.
Trần Tân Thịnh.
Yes, sir.
Đồng Quốc Thống.
Yes, sir.
Đặng Đức Toàn.
Yes, I'm here.
Trần Lê Trung.
Yes, I'm here.
Nguyễn Ngọc Vinh Trường.
Yes, I'm here. I'm here.
Nguyễn Thanh Tùng.
Yes, I'm here.
Yes. Đặng Hoàng Việt.
Yes, I'm here.
Lê Quang Vinh.
Yes, I'm here, sir.
Lê Thanh Đạt.
I'm here, sir.
Phạm Hồng Đức.
I'm here, sir.
Okay, thank you. Nguyễn Đoàn Dũng. Okay, wait a moment. Yes, okay, I see your hand. Nguyễn Vũ Anh Khoa, are you here? Nguyễn Thành Lộc. Okay. So let's I review the chapter number 5. Wait a moment. Slide. Sorry. This slide. Okay, I have extended the deadline for the homework. Okay, I'm sorry, we have not finished the chapter number 5. So that the homework number 4, and I will extend until Friday. Yeah, however, many students have submitted. I'm very surprised. Yeah. We have not finished the chapter number 5, but you have submitted already homework. Yeah, how can you do homework?
I just I search around the internet for a
Oh,
way, and
yeah.
I also use maybe what they say about using apply what the main function you would normally compile in C. I just write it in assembly instead.
Yeah, I think it's
Uh,
very good. Okay, so let's review. Okay, I think the assembly language, when you try to use the Visual C programs and you just write the keyword like this. Yeah, ASM, open and close, and you can easy uh, to write the assembly programs. Okay.
but when I
Uh,
write dash ASM like that without in any function, it will throw an error while compiling.
mm, without any function, what do you
Yeah,
mean?
I mean, I put it in a main file with it not inside a function. Like instead,
You have
for
to add in the main function.
uh,
Sorry, main. Yeah, you have to write in the main, and yeah, like that. Okay. And remember, now when I show you the assembly language here, this is the Microsoft assembly. Okay, because we have not just only one assembler. We have the Microsoft assembler, GNU assembler, and NetWise assemblers. So normally the Microsoft assembler used in the Windows, and we can use the Visual C Studio. If you use the DevC, because DevC use the GCC, yeah, DevC use the CCC compiler, so they use the GNU style. Yeah, they do not use the Intel. They don't like Intel. Okay, they use the GNU assembler. So if you use DevC, you have to follow the instruction like this. Uh, and here I show you some difference between the Microsoft assembler and GNU assembler. Okay, you see. For example, you apply move, it's different. Move destination first and source later. And if you write the register name, you have to write the percentage symbol. Okay. If you write the constant data, you have to write the dollar symbol. You see. And for the memories, they use the open and close bracket like this. But in the GNU, they use different. Okay, different symbol. Okay. I think we have solved the problem, this one already. Now, continue. I explain you about the branching and looping function operator. Okay. For branching and looping, you can use the jump instruction. We have two kinds of jump: unconditional jump and conditional jump. Conditional jump and unconditional jump. For unconditional jump, you just apply JMP. Very easy. Just apply JMP and the label. And when you write the label, you just write the name and the product here. And the assembly language understand this is the label, and I can jump to the label. You also can jump to the any address or jump using the register name. Store the address inside. Okay, you can store some address in the register, and you apply jump to the register, indicate the address. And for unconditional jump, we can apply some operation like this. I show you here. Table. we have two kind of table. The first one for the unsigned operands. The next one is for the signed operands. For the unsigned operands, we can apply here chum if above, chum if not below or equal. Okay, you just see the name JNBE, JAE mean chum if above or equal. JNB, chum if not below. Okay. It's not difficult to guess the meaning. Next one, for the sign operands, you can apply chum if greater, chum if not less than or equal. You see, it's not difficult to guess the meaning. And how it works, how the processor can know the value is greater or not, or less than or equal. Very easy, you see. The processor will check the flag register, because after you apply some comparison or you apply some arithmetic instruction, the results will affect to the flag register. We have many kind of the flag. Let's see here. Okay, this is the flag register. I show you already. Yeah, the flag register, they have some information about what kind of information, overflow, direction here, many kind of flag, size, zero, auxiliary, carry, parity, carry. If you don't understand any flag, I think we can check the example. Okay, we just write the name of the flag and the register name, the flag register, and you also can test the results in the Visual C programs. Okay, try to make some arithmetic instruction, and then we check they can affect to the flag register. Example, the zero flag, very easy, zero. If the result is zero results, the flag will be 1, becomes 1. Okay. Now let's see the example. I think very easy if we apply in the example. Let's see. At first we apply CMP. CMP means compare. Compare the register EAX with the value 100. And JA, what does it mean? JA means jump if above. Jump if above. And we go to the label bigger. This is just the label name. Another example. If value less than 10, add 1 to the small count. If not, add 1 to the large count. Now we write in the assembly language. CMP compare EBX with the number 10. Jump if not less than. If not less than. Okay, not less than is mean is the correct, the expression here is wrong. Okay, we go to the L large here. Add 1 to the last count here, increase 1. Okay, and if the condition is here, jump if not less than, it means that if the result is less than, they go to the next instruction, increase mode count. You see, increase mode count. Okay, and remember we have to add the jump instruction here, because if we do not apply JNB, I will continue go to the next instruction. The next instruction is increase. Okay, it's not. We cannot apply increase last count, because increase last count for the case L. Okay, and we have to apply jump to the n value check. jump to here. Okay, to make sure you understand, I think now let's try to do this example. Can you do? Okay, please discuss in group together how to write assembly language for the code here. Okay, this is the pseudo code. How to do? Okay, I give you a hint. At first, we apply CMP, compare. CMP, compare the total with the 100. Yeah, please try. Okay, when you finish, please raise your hand and show me the results. Let's I check again. Nguyễn Vũ Anh Khoa, are you here? Not here. Phan Hoàng Lê Minh, oh sorry. Nguyễn Thành Lộc, It's not here. Okay, please discuss together and show me the results. Sorry, not this slide. Yeah, you are right here. The comparison total and 100. If the condition is correct, and we don't care about the next condition because this is the or. Okay, or is mean if this one correct or this one correct, and we apply. Okay, I see. I hear some raise your hand. Thành. Okay, thank you. Can you show the results?
So I will share my screen.
Okay.
Yeah. Can you see my screen now?
Yeah, I can see. Wow, you drive in the Visual C program. Very good.
The first because it's the OR operation, so we just need one condition is the true value. The first one, we will compare the total with 100, and if it's right, we will jump greater, and the condition is greater or equal. And then after that, if it's the true, we will move to the add label. If not, we will check a second condition. It is count and number 10. And if it's not true, it means that count is not equal to 10. We won't do anything, and we will move to done. And if it's right, we will add the value.
Yeah, it's very good. So can you run the programs?
Yes, sir. You can see the first condition, my total is 60, and the first condition is wrong, but the count is you see it is my initial.
Yeah. Can you show the output window? I cannot see the output window.
Okay, sorry. I will share on internal screen. Check. Here.
Yeah, the output window is 70, 10, and 10.
It is the total count and value respectively.
Yeah, I think it's very good. Yeah, you have the correct answer. Thank you. Give a big hand for Mr. Tan. Okay.
Thank you.
And
Sir.
yeah, and go to the next example. Okay, let I show my screen. So in the next example, we see that we have the loop, the looping. This is the while loop. To apply the while loop, we try to declare the condition. Okay, because in the while loop, we check the condition first. If the condition is correct, and we continue to the body of the while loop. And finally, we jump to the beginning of the while loop and we check the condition again. If the condition is not correct, and we finish the while sum. Okay, in the next, this is the summary for the while. Okay, I think it's not difficult. Just follow the example and try to do this one. Okay. Yeah, just you see, this is example while loop. I think you can do it very easy. You just write while the label like that, and try to compare CMT sum in 1000. Yeah, and do more. Okay, let's discuss together to write the code for the looping while. Yeah. Okay, in the loop, maybe you can write any instruction for your testing. Okay, so can you do?
Give me a second, sir.
Okay. And when you write this one, when you use the comparison, please remember that you can compare between the register and the number is okay. Example EIX, sorry. You can compare EIX, EPX, it's okay. You compare the resistor and the constant, okay. You compare the resistor and resistor, okay. You can compare the memory. Maybe the memory is some with the resistor, okay. But you cannot compare two memory. For example, you compare like that. So the instruction do not support to compare between two memories. Okay. I just give you the notation here. And if you want to compare two memories, you just move. Yes, maybe you compare A and B like that. Okay. You have to move to the EAX first, maybe like that, and then you can compare two values. So in this case, sum is memory. Okay, yeah, you can compare sum, and you can use the constant number function. Remember, this is the AND logic, and it means we have to check two conditions. If the condition is not correct and we exist, not correct is mean not less than, okay, not less than J and L, not less than and we exist Y, exist Y, okay. Okay, anyone can show me the solution? Yeah, Mr. Thành again. Any other? Raise your hand. I think Hải. Okay. Yeah, please. Mr. Hải, can you share your screen?
Yes, this is my screen. I write it purely in NASM.
Wow, why you try many things? Okay.
So here's the primary one. This is the test for the while, and then
Yeah.
this one is I just add it so that it will add into the sum 1 by 100 and then increase the count up. So that just to match the case of so that it can get out to this one if it's not satisfied anymore.
Yeah.
Here is the program in run. I'm sorry, it's in press the button wrong window.
Oh. Can you show your screen again? Yeah.
All right. Here it is. This is before going through the while loop, and this is after going through the while loop.
Oh, very good. Okay. So show me again the code. Okay, so your full code.
Yeah. Let me zoom out a bit.
Okay. Yeah, very good. So you write the assembly programs. Yeah. Wow, very good. So you use the Visual Studio.
Yes,
to
I
write.
use Visual Studio and I compile this assembly file using NASM, and then it's
Ah,
linked with the library, with the C library.
yeah, very good. And you call the printf again to show the results. Yeah, very good when you write the assembly language. Yeah, because in the example, all the example in the class, I show you to mix the code between C and assembly. Because when we want to show the results on string, we can easy to show by the cout instruction. Okay, in the assembly language, we need some library to show the some value on string. So in here you use the call printf, okay, printf function. Yeah, very good. Yeah, you use the library from the Microsoft Assembler. Also, do you need to install some another library? You just install the Visual C Studio is enough?
Yes, I just use Visual C Studio or with Visual C++, and I have to declare extra libraries because the printf symbols is not available to be
Yeah,
used.
yeah. Can show me how to declare.
Yes, I use going from this, and then I just use in link input. I add extra three more, so that it can link the printf and the scanf. I will use the scanf
Okay.
in inputting. I have to use free libraries. This one UCRT and SVCRT.
Yeah, the stdio definition lib. Okay. Where did you get the library here? The lib file.
The library is included with the when I install Visual Studio.
Okay. Yeah. Yeah, very good. Yeah, you have tried the assembly program, the full assembly programs. Yeah, very good example. Thank you,
Yes.
Mr. Hai. Yeah. And also everyone, yeah, you can use the program emulator A0, A6 emulator. Anyone in our class use some emulator? Yeah, we Vinh Hảo, but can you run your programs? How? Uh, can you show the results? Yeah. Okay, yeah, very good, very clear. Okay, so all the students in class, you can see your friends. Okay, Mr. Hảo use the emulator A0, A6, and we also can use this software to simulate your assembly code. Okay, show me the CMB. Okay, will you compare sum with the 1000s and apply JNL? Sum if not less than with the label NY sum. Okay, and apply CMB count with the 24. Sum if not less than or equal. Okay, go to the NY sum. And if all the condition true, and now we add the value ax and bx and move ax to sum. Okay. Can you run your emulate your programs? Any wrong parameter? Some is do not match a bit and 16-bit register. Okay, please try. I think you declare AX. Do not write AX again. Okay. Yeah, AX and BX is 23. Next one BX. Okay. And no, finally you have AH. Move which modify AX. Move AX for C. You see add the label NY sum. Why you move for C? Okay. Now trying to run. Any error? Is still error? Okay. Yeah. Thank you. Yeah, very good example. Okay. Thank you, Mr. Hảo. And now I show again my screen. Yeah. So you can have many kind of tools to simulate your assembly programs and try to do. Okay. And next one I introduce about the procedure. And here procedure, when you apply procedure, you just apply call. Okay. And how to define the procedure. I give you the example here. Okay. For example, you have the procedure root, mean we apply the root operation for some number. This is the square root. Okay. And before to do some instruction, please apply the boost instruction. Boost, what does it mean? Because the register A, B, C, D something, normally they use for some the main programs. And when you call the instruction, when you call the procedure, and in the procedure, if you want to use some register, and before using, we have to store all the previous value into the stack memory. Here, we store in the stack memory by using the instruction boost. Okay. And after we apply boost, then the register EBX, ECX you can use. Anything you can use. You can modify the value of the EBX, ECX. Okay. And before you finish the procedure, you apply both again. Both is mean restore the value of the register. Restore, what does it mean? It means we copy the data from the stack memory. You copy back to the register. Okay. It means that at the beginning of the procedure, you save the value in the stack, and before complete the procedure, you restore the data in the register, and then you call the return instruction. Okay, return is mean we return the place when we call this function or this procedure. And how about the argument in the C programs? When you write the function, maybe you put some argument for the function. In here, you can do like this. You can assume that the argument in some register. Yeah, maybe in here. In this example, the argument in the register EAX, okay, and the square root will be returned in the EAX register. Okay, this is another example. And we have some example on the assembly programs. Okay. Anyone can write the Tower of Hanoi in the assembly language. Okay, this is the pseudocode and how to display all describe the code here using the assembly language. Okay, I think just try to do many examples as you can for the assembly language. And I think it's not difficult to solve the problem for the homework number 4. Where is the homework? Okay, so please submit the homework number 4. As I open the homework number 4. And we have the for loop. Okay, I think the first question is easy for you. You can test it by the Visual C programs. For the for loop, okay, and for the function, try to do write the function in the assembly language. In here, in the function, you see that we have the argument. We can assume that the argument in some register, for example, the M and N here, in the register A or B or C. Yeah. Any questions? We can go to the next chapter, chapter 6. Okay. Yeah, let's open the full screen for the chapter number 6. So for the chapter number 6, I will introduce you about the interrupt and the handle. Okay, and please read the textbook Understanding Linux Kernel, the chapter number 4, interrupt and exception. I upload the textbook already in the BK e-learning website. And what is the purpose of the interrupts? You see here, this is the main programs, and normally when you run the main programs, and sometimes the peripheral require the processor to do some service, okay, to do some service, and the main program has to be stopped, and after that the interrupt service running. This is a kind of special program run to service the peripheral, and after we finish the service routing, and we go back to the main programs. Okay, continue. Okay. So that is a kind of the purpose of the interrupt. It means the processor process the main program, and sometimes they have to stop to do some service for the peripheral, and they can stop, and after they finish, and they go back to the main programs. And just continue. And we have some terminology for the interrupt. At first, I explain interrupt pin. Interrupt pin, that is a kind of pin in the processor. When we trigger the pin by the signal, and it means that the device require the interrupts, okay, or request the interrupt. Interrupt service routing, this is a kind of interrupt handle, special programs to service the interrupt. Interrupt priority, Sometimes multiple interrupts happen, and we have to identify which one will run first. It depends on the interrupt priority. Interrupter, this is a kind of address, to determine the address of the interrupt service routine. Interrupt service routine, this is a kind of function, a kind of subroutine programs, and we need to identify the address of the ISR. And when we have the address of ISR, then we can call the function to make it run. The interrupt masking. Masking is mean we can mask or unmask. It means we can enable or disable. We can enable the interrupt or we can disable interrupt. It depends on the parameter. We can write the instruction to enable or disable interrupt. But some interrupt is cannot be ignored. It means there is the non-maskable interrupts. For example, the power down interrupt, reset interrupt. Okay, reset. That is the kind of non-maskable interrupt. Here, this is the interrupt processing flow. In the main programs, if we have the signal at the interrupt pin and trigger the interrupt, and the CPU will consider accept interrupt or not, depend on the configuration. We enable the interrupt or we disable interrupt. And if the interrupt is accepted, and the processor will get the interrupter from where? They get the interrupter from the peripheral device. The peripheral device has to send the interrupter to the processor, and the processor use the interrupter to get the address of the ISR. Because there are many ISR programs, we have multiple ISR programs. Depend on the interrupt, we will decide which ISR run, and we get the address of the ISR and we call the function. Before to run the ISR, we have to set the BC. BC means program counter, and we set the program counter. It means program counter is the address of the current instruction in the main programs. And after we complete the ISR, and we restart the BC, restart the program counter, and continue to the main programs. Okay, that is the interrupt processing flow. Now I explain what is the difference between interrupt and exception. You see in the detail in the next slide. Normally, the interrupt indicate the event from the external hardware. External hardware, it means the external hardware trigger the interrupt pin, for the interrupt request, and the processor will process the interrupt by get the interpreter and identify the address of the ISR and run. Okay. How about the exception? Exception is different. Exception is not come from the outside, the external hardware. Exception come from the internally, from the CPU. Normally, the exception used to indicate the error conditions, and they are generated by the CPU, by the software. You see, it's different. Interrupt from the external hardware, exception from the software, from the CPU. There are two types of interrupts: maskable interrupt and non-maskable interrupt. There are three kinds of exception: for trap and off. Okay? we divide the exception type depend on the behavior. Okay, fault is mean some error, but it can recoverable. Okay, can be recoverable. It means the program can continue to run. Yeah, it can solve the problem. For about the trap is mean the programmer can make some trap to solve the problem of the error in some error in the software. What kind of error? Many kind of error. For example, you enter some input value, but you enter some wrong value. How can we solve the problem? We make a trap. We make a trap to recover the problem. Okay. Airport is the unrecoverable problem. For example, the memory error. Yeah, we cannot recover the state of the CPU. Yeah. Some error is the serious error, such as the memory fault or memory conflict. Yeah. Okay, I show you some exception type. Okay, yeah. Many kind of exception. You see, abort. Okay, abort is the serious error come from the software or from the CPU. Okay, there are many kind of exception. Okay, next I explain you about the x86 interrupt pin. In the processor, we have the interrupt pin INTR, INTA, and IA. NMI, that is non-stackable interrupt. If we want to request the interrupt, we do like this. At the beginning, when the level interrupt pin level 0, and we trigger the pin to 1. Okay, from 0 to 1, we trigger, and then the processor will respond the interrupt by applying the interrupt acknowledge go to the low level. Normally it's in the high level, and you see the special symbol INTA desk. Okay, this symbol means the interrupt pin, this pin have the low active. When low active, it means active at the 0 level. And when the interrupt acknowledge respond, and after that the device on the peripheral send the vector data to the processor, and the processor receive the vector data. Okay, let's review all the questions here. What are the purpose of the interrupt? Okay, describe the interrupt processing flow. It's easy. To answer the questions, you just go back to the slide. On the first slide, you have the purpose of the interrupt. You have the interrupt processing flow. Okay, we can easy to answer the questions. It's easy. Then let's take some minutes to review the questions. Discuss in group together. We have the group together. Okay, please discuss and answer the questions. As I check the present attendance. Nguyễn Vũ Anh Khoa, are you here? Thành Lập. Absent. Okay, I think I go to the next slide because this one easy to answer. Next is more important about the interrupt. Okay, we have to understand the interrupt vector. because the interpreter is a kind of indicator, to determine the accuracy of the ISI. Okay, we use the interpreter to determine the accuracy of the ISI. How to determine? How can we do? We do like this. Okay, go to the next slide. In the A0AA or A0A6, we have the interpreter table. And how to manage the interpreter table? Interpreter table, that is the table store all the address of the ISI. Because we have many kind of ISI. We have different device, different external device, we have different peripheral device. So that we also have many different interrupt subrouting programs. Okay, and the interpreter table store all the address of the ISI, and this table locate on the memories from the 0000 to 003FF hexad. Okay, this location in the memories. And remember, this is for the real mode. Okay, we have two kind of mode: real mode and protected mode. Okay, different mode to manage the interpreter table. We have, okay, this one for 32-bit mode, this one for the 16-bit mode. Because now we study the A0AA, A0A6 processor, so we try to focus on this. The interpreter table have the entry. Okay, for each entry they have interpreter. They have 4 bytes. Okay, for each entry. 4 bytes here is 2 bytes for the offset address and 2 bytes more for the segment address. Okay, we have segment address and offset address. The total 4 bytes. I explained for the protected mode. So for the protected mode, it's different. They try to store the address of the ISI in the interrupt register table. The interrupt register table can locate it anywhere in the memory. Okay, anywhere. So how can we find the location? We use the register IDTR. Okay. The IDTR register store the starting address of the register table. And each entry in the interrupt with the register table is 8 byte long, 8 byte. Okay, this reference here. In the remote 16-bit, each entry only 4 byte. But here they are 8 byte. 4 byte for the offset, 2 byte for the segment, and the rest information means 2 byte for the privilege level. Privilege level, that is the account permission to access the interrupt subroutine, sub-interrupt subroutine. Now I will show you how to connect in the circuit. Okay, how to connect the A0AA or A0A6 processor with the peripheral device here. How to connect? Two examples, this one or this one. We can connect the peripheral device and the processor by using the AOS244 chip. This chip use the this chip is the buffer chip. Buffer chip. This is the buffer chip. This chip is the buffer chip, and this one run like this. When you enable the enable pin, okay, this is the enable pin E1 and E2. They are two pins for the enable chip. When you enable the chip, the output signal will become the input signal. This means the output data will get the value from the input data. When the enable pin is active, if the enable pin is not active, what happens? If the enable pin is not active, the output data keep the same with the previous state, keep the same. It means no change. And when you apply the enable pin active, when the enable pin active, the output data will get the value from the input data. What is the value of the input data? Yeah. You connect to the power and the ground. Okay, power and ground. 0, 0, 1, 1, 0, 0. This one is 1, and this one is 0. So we have the value 0, 1, 0, 0, 1, 1, 0, 0. That is the 4C in the hexadecimal number. And when the chip is active, you see, interrupt pin. We connect interrupt pin from the peripheral device. Connect. Okay. When you connect interrupt pin and you connect to the enable pin already, you connect and you combine together with the interrupt acknowledge. Yeah. You check the timing diagram like this. Okay, you see, when the interrupt request active and the interrupt acknowledge also active, but the interrupt pin active in the high level, the logic 1, interrupt acknowledge active at the low level, logic 0, and you combine together to enable the chip LS244, and then we get the vector. Yeah, you see, and we get the vector. And you can define the vector of the interrupt here. Very easy to define. You just connect to the power and ground. Okay. And yeah, can you do this example? Yeah. Just review the previous slide, this one, and then we do this example. Discuss in group together. Okay, let's 5 minutes discuss in group together to draw the circuit diagram. Yeah, okay. To show how a device with the interrupt vector 58 can be connected with the A0A processor. Okay, please discuss together to answer the questions. Okay, so discuss in 5 minutes. Discuss in group together. Maybe. Do you have the answer? As I call somebody, Mr. Trương, Nguyễn Ngọc Minh Trương. Are you here?
Yes, sir.
Yeah. Have you done
I
the
don't.
example?
Yeah. No, sir.
Yeah, we have the example in the previous slide. Okay. I think it's easy to draw the picture, to draw the diagram, circuit diagram, and you can modify the interrupt vector data here. Do you understand how to do? Mr. Trương, have you discussed in group together?
Yeah. We try, but we don't have the idea.
Yeah. So which one you do not understand in this picture? You see this diagram. We have the chip LS244. This is the buffer chip. This means when we active the enable pin, and the output data will get the value from the input data. And this is the interrupt vector value. If you want the processor get the interrupt vector, maybe 4C or any value, 58, and you just set it here. Okay, apply the configuration here. If you want to 0 value, connect to the ground. 1 connect to the power. Okay, and we connect the peripheral device with the interrupt request pin like this, so that we can communicate with the CPU. Okay, and request the interrupt and send the interrupt vector. Let's say I ask somebody else, Nguyễn Hồng Đức, Phạm Hồng Đức.
We are discussing now, sir.
Yeah, please try. Okay, I think it's not difficult to draw the picture, to draw the circuit diagram. For this example, I will explain the next slide, and we do some example. In the next slide, okay, someone raise your hand. Vinh Hảo, okay. So you have the answer. Okay. Yeah. Yeah, 58. Okay, 58 hexa. Okay. Yeah. Okay, it's fine. You can set up the value. Okay, we set up the value from yeah. Yeah, very good. Yeah, how? Yeah. Thank you. Yeah. I think yeah, we can easy to do the example because we have the previous example with a similar case. In the next slide, I show you how to get the address of the ISR. So in the previous example, we have the interpreter already. This is the interpreter. And from the interpreter, we can get the address of the ISR. How to do? I give you the example. This is the ISR table. This is the interpreter table. All the value here, just the example. Okay, we can easy to modify the value by the software. The programmer can setting, can change the value of the address in the interpreter table. And for example, we have the interpreter 42, and we do like this. We multiply 42 multiplied by 4, and we have the value 108. Remember, this is the hexadecimal number, so when you multiply, you have this value. And this value will be the location of the address of the ISR. So we take 4 bytes from the address 108 here. This is the 00100, 00101, 2, 3, 4, 5, 6, 7, 8 from here. So this location is have the address 00108, and we take 4 bytes. Why we take 4 bytes? Because in the definition we explained already. Here for the remote we explained already. Each entry in the interpreter table is 4 byte long. 2 bytes, the first 2 bytes for the offset address, and the last 2 bytes for the segment address. Okay, and then you see 108, this location for the offset low. The next one for the offset high. Next one for the segment low. Next one for the segment high. Okay, and then we can get the results. Yeah. Now, how can we change the value of the interpreter table? we can apply the move instruction. Okay, here I want to modify the address of the XR for the interpreter 40 exact. We do like this. We multiply 40 multiplied by 4, and we have the location in the interpreter table. The location is 100 hexad, and you copy the offset address to the location 100 hexad. You copy the segment address to the location 102 hexad. Why 102? Because for the offset address, we start to the location 100 and 101, okay, 2 bytes. And for the segment address, we start to the location 102 and 103. Okay. Remember, the register AX is the 60-bit register. When we move here, it means we move 2 bytes. At the same time, we move 2 bytes. Okay. Based on this example, we do the assignment here. Yeah, I give you some hint over here, and please try. Okay, let's 5 minutes to discuss together to do 2 examples. Let's discuss together. So at first we have to multiply this value with number 4. And then we can get the location. Yeah, the location in the interpreter table to find the address of the ISA 3E4. Okay, please check the 3E4. 3E0 here, 3E0, 3E1, 2, 3, 4 here, over there, here, this display, this location. And in this location we have the 4 byte, 4E33 6F 90, and we get 4 byte here for the offset and the segment address. Okay, and we'll get the results. 4E33 6F and 90, and we get the results for the offset address, segment address. And finally, if you want to get the full address, 20-bit address, okay, full 20-bit address, you can apply the addition. Sorry, I have the wrong answer here. We have we have to write the segment address first. And add the 0. 0 means we shift for bit. Okay, we shift left for bit for this value, and we plus with the offset address 3348, and we get the result. Okay, you use your calculator to get the value. And the next one, how to write the sequence instruction that initialize the vector 42 hexa point to the ISA. This is the label for the address of the ISA, and we want to copy this address to the location in the interpreter table for the vector 42s. Okay, so please check this example and try to do. Okay, let's discuss together to get the results. Any questions? I think it's easy. Yeah, we have example already. Okay, in the next slide, I explain about the interpreter. You see, for the A0A or A0A6 processor, they define already 256 different interpreter. Okay, they define already. So we have the all definition here. The interpreter 000 is that is the type 0. Okay, we have they define already. We just use some interpreter for the user here. From the 32 to 255. Yeah, that is the all the interpreter for the user. And remember, from 0 to 31, that is for the system. Okay, and we do not use for the user. We only can use from this vector 32 to 255. Okay, and next I will explain about the register table for the protected mode. And remember, I explained two modes here. The first one for the real mode, apply for the A0A, A0A6 processor. For the protected mode, we apply for A03, A6, A04, A6. Okay. And for the A03, A6, 4, A6 and Phantom, we use the protected mode. In the protected mode, we have the interrupt register table contain 8 bytes for each entry, not just only 4 bytes, 8 bytes. Where is the 8 byte? Here, I show you where. Here, this is the 8 byte. Okay, you see, 4 byte, 4 byte. Yeah. So for the 8 byte, we have 4 byte for the offset address. Okay, 4 byte, 2 byte here, 2 byte. 4 byte for the offset address, 2 byte for the segment address, and 2 byte for the privileged level information. Okay, you see here, they have some information for the privilege level, for the flag, the present flag. Okay, present flag like mean they indicate that the data now in the memories or not, because for the virtual memories, sometimes the data is not located in the memory. The data is located in the hard disk. I will explain the detail about the present flash in the next chapter, okay, about the virtual memories. So in this part, you see each entry contain 8 bytes, 4 bytes for the offset address, 2 bytes for the segment, and the rest one is some privileged information. This is the detail, okay. And finally, how to get the address. This one. You have the offset address and you have the segment address, and then you can find the interrupt address. Okay, the address for the ISR is mean the address for the interrupt procedure. Okay, based on two information. And about the interrupt, the A0, A6, the x86 processor, they define already the interrupt. Here, I show you the interrupt vector NN. We described already in the previous slide. Yeah, this one. Okay, and please keep remember they define already, and we only can use from this interrupt vector. Yeah, in the next slide, we show you the how to manage the interrupt, because maybe we do not have only one peripheral device. We can have more than one. For example, we have 8 devices or more than 8, and we can use the PIC chip to manage the interrupt device. The PIC means programmable interrupt controller, the chip A259 chip. Okay, and to check the information for the chip, we can use the go to search the dataset. Okay, to try to search the dataset A259 chip. We search the chip A259, and we can get the results. How to connect? We do like this. We connect the. Okay, I go to the full screen mode. Connect the chip. The data pin connect to the data. Chip select connect to the configuration for the address. Yeah, depend on the address you want to identify the address for this chip. We use some combination logic here. read write connect to the read and write signal. Interrupt pin connect to the interrupt request pin. Interrupt acknowledge, okay, connect to the interrupt acknowledge. And after that, you can have a pin for the interrupt request. So for the A pin here, you can connect 8 device. Yeah. So the chip A259 can manage the maximum 8 device for the interrupt source. If you have more than 8 device, how to do? If you have more than 8, you can do like this. Yeah, okay, this slide. This is just the block diagram. You can check the detailed circuits in the datasheet. But I show you the block diagram first. You can take one interrupt pin from the master PIC, connect to another interrupt pin of the slave PIC. Yeah, like this. Yeah, we have 8 interrupt source, and you add one more A259 chip, another A259 chip, and you connect just one interrupt request pin, connect to the next chip A259, connect to the interrupt pin here. Okay, and also the CSA, the cascade mode, we have to connect together. I will show you how. To here, and we check the dataset. I remember I download the dataset already. I'm not sure. You can go to the Google, okay, to search the dataset. I need to find out. Yeah, this is the chip A259, and we can easy. Sorry, here. Open the dataset and check the last line, the last page. Okay, I scroll down. Yeah, this slide. Can you see clearly? Yeah, for the cascade mode, you have to connect together. Okay, connect the cascade mode together, and you set up the master A259 and 2 other slave A259, and from the master here, you just select any pin from the master, connect to the interrupt pin for the next one. Yeah, and maybe you select the interrupt pin number 3 and connect to the interrupt pin, input interrupt pin for the next slave chip. Okay, and continue. You can select any pin to connect another slave. Okay, that is the how to extend the interrupt source. Okay, for each A259, we can manage 8 source of the interrupt, and we can add more slave chip to extend the interrupt source. Okay. Yeah, I think it's enough for today. And let's review all the chapter, read the slide, and do the example. I will review
Could you
again.
please?
Okay.
Could you please open the homework for resubmission?
Homework number 4. Homework number 4. Okay. So, do you have any questions for the homework number 4?
Oh, I asked you to reopen the homework so that I can resubmit the newer versions after today's lessons.
So you can submit again.
No, when I submit, I don't see the edit anymore. They ask they ask me to accept it as a big project, so I cannot modify it after I press send.
Homework. So you cannot submit the new version. You cannot.
Yes.
I don't know how to.
The line that said about accepting the status of the submission, the second one in the thiết lập bài nộp.
Okay. So do we need push the button nộp bài? Maybe no, we don't need. Maybe this. Yeah, okay, I think so like this. You can submit again. Okay. You can submit another version. Okay, you just write the new version. It's okay. I set up here. Wait, I press the button. Okay, please check again.
Teacher.
Yeah.
For the 50% project submission, do all of the members in the group have to submit it, or just one person to represent to submit that?
Yeah, just one member in your group submit. Okay.
And it said that we have to submit in Word file. Can I submit that in PDF file?
Okay. PDF or Word file is okay.
Yeah, thanks.
I still don't see where I can resubmit my file.
Oh,